Welcome to Science for Sleep. Tonight, we're exploring a question so vast that it stretches beyond the edge of the observable universe. A question that sounds impossible, yet quietly emerges from some of the most serious mathematics in modern physics. Are there infinite versions of you? Living different lives, making different choices, existing right now, beyond what we can see? At first, this sounds like science fiction, something pulled from movies, novels, or late-night speculation. But the idea of a multiverse does not come from imagination. It comes from equations. Physicists did not set out to invent parallel worlds. They were trying to understand reality. And reality, it seems, may be far larger than we ever expected. To begin, we need to step back, far back, to the largest structure we can observe. The universe we see is immense, billions of galaxies, each containing billions of stars, each star potentially surrounded by planets. But even this staggering expanse has a boundary, not an edge you could reach, but a limit to what light has had time to reach us. This is called the observable universe. Beyond it, space may continue, possibly forever. And that possibility alone leads to something strange. Space is infinite, and matter arranges itself according to physical laws. Then patterns must repeat. Not immediately, not nearby, but eventually. In an infinite universe, every possible arrangement of matter occurs, including one exactly like Earth, exactly like you. Reading these words, this is not speculation. It is a consequence of infinity. Physicist Max Tegmark calls this level 1 of the multiverse, the simplest version. No new physics required, just endless space. Far beyond what we can see, there may be another Earth, another you, living a life almost identical, until one small difference appears. A different word spoken, a different decision made, a slightly altered path. Already the idea begins to feel unsettling. But this is only the first layer. To go deeper, we need to talk about how the universe began. Modern cosmology tells us that the universe expanded rapidly after the Big Bang, a process known as cosmic inflation. Inflation explains why the universe looks smooth and flat, why distant regions look similar. But inflation may not have happened just once. Some theories suggest inflation is ongoing, that space continues to expand in different regions, creating vast, separate bubbles. Each bubble becomes its own universe, with its own laws, its own constants, its own version of reality. This is called eternal inflation, and it leads to level 2 of the multiverse. In these universes, physics itself may differ. The strength of gravity, the mass of particles, the speed of cosmic expansion. Some universes collapse instantly, others never form stars. A few, by chance, support complexity. Life. Observers. This is one explanation for why our universe seems finely tuned. We exist in one that allows existence, not because it was designed, but because all possibilities exist. And we happen to be in one where we can ask the question. Already you can feel the scale growing, but we're not finished. Now we reach the most famous and controversial version of the multiverse. Comes not from cosmology, but from quantum mechanics. Earlier we explored how particles exist in multiple states at once, until measured. One interpretation suggests something radical, that all outcomes occur. Every quantum decision creates a branching universe. This is the many-worlds interpretation, proposed by Hugh Everett. In this view, the universe does not collapse possibilities, it splits them. Every time a quantum event has multiple outcomes, reality divides. One version where you turned left, another where you turned right, one where you spoke, another where you stayed silent. These universes do not interact. They do not communicate. They simply coexist. This leads to an astonishing implication. There may be countless versions of you, diverging with every quantum moment, not metaphorically, but physically. Some physicists accept this interpretation, others reject it, but none can easily disprove it. Because all interpretations of quantum mechanics predict the same outcomes. They differ only in what they say reality is. And that's where the question becomes personal. If every possible version of you exists, what does that say about identity? About choice? About meaning? Before we go there, let's pause. Notice how calm this idea actually is. No universe replaces this one. No copy erases you. You are still here. Still singular in experience. Still real. The multiverse does not diminish your existence. It deepens it. When people first hear about infinite versions of themselves, the reaction is often emotional. Curiosity, discomfort, wonder. Because the idea touches something deeply personal. Identity. So before going any further into physics, we need to pause and ask a quieter question. What is you really? In everyday life, identity feels continuous. You wake up. You remember yesterday. You recognize your name, your body, your thoughts. But neuroscience tells us something surprising. The self is not a single thing. It is a process. Your sense of identity is constructed moment by moment. Memories stitched together. Sensations integrated. Emotions interpreted. There is no single self-particle in the brain. No fixed center. Just patterns. This matters in a multiverse. Because if identity is a process, then multiple versions of that process can exist independently. In the many worlds interpretation, when reality branches, you do not split. Instead, two future versions continue from a shared past. Up to that moment, they are identical. Same memories, same personality, same awareness. After that moment, they diverge. Each experiences their own timeline. Each feels singular. Neither feels copied. Neither feels replaced. Each feels like the original. This is one of the strangest implications of quantum theory. Subjective experience does not notice branching. From the inside, there is always only one path. This leads to a profound realization. Even if infinite versions of you exist, you will only ever experience one. Your consciousness does not jump between universes. It follows a single thread. From your perspective, the multiverse is invisible. This is why the idea doesn't disrupt daily life. No one feels split. No one senses alternatives. The multiverse, if it exists, is a background structure, not a lived one. Now let's address a common misconception. People often imagine parallel universes as nearby places, worlds you could travel to, meet other versions of yourself. But in most scientific theories, this is not possible. Other universes are not elsewhere in space. They are separate in structure. In eternal inflation, universes are separated by expanding space faster than light. In many worlds, universes are separated by quantum decoherence. No bridge. No portal. No crossover. This is why multiverse theories remain untestable in many cases. Not because they are unscientific, but because they exist beyond current experimental reach. Some physicists are comfortable with this. Others are not. Science prefers testable predictions. And the multiverse challenges that preference. Still, the theories persist, because they arise naturally from equations that work. Now consider something more subtle. If all possible versions of you exist, does that make choice meaningless? At first, it might feel that way. If every decision happens somewhere, what does your decision matter? But this is a misunderstanding. Meaning does not come from exclusivity. It comes from experience. Your choice matters to you, because you live with its consequences. Other versions do not erase this one. They do not dilute your story. Each universe contains its own narrative, its own causality, its own meaning. From inside a universe, outcomes are real. From outside, if such a perspective exists, reality may look vast and branching, but lived experience remains local. Now let's move to another version of the multiverse. One that feels less personal, but no less strange. The mathematical multiverse. Physicist Max Tegmark proposed something radical. That all mathematical structures exist physically. If a universe can be described mathematically, then it exists. Under this view, reality is not special. It is one of many consistent mathematical systems. This implies universes with entirely different logic, different dimensions, different concepts of time. In some of them, you cannot exist at all. In a few, something like you might. This idea is extreme and controversial, but it emerges from a simple question. Why does this universe obey mathematics so perfectly? Perhaps because mathematics is reality. Again, no proof, but the idea lingers. As you rest with this thought, notice something gentle. The multiverse does not ask you to believe. It asks you to imagine possibilities larger than certainty. In the next part, we'll explore evidence, limits, and skepticism. Why many physicists doubt the multiverse, and why others think it may be unavoidable. For now, let identity loosen its grip. You don't need to be infinite to be enough. Up to this point, everything we've discussed has emerged from serious science, from equations that work, from models that predict reality with extraordinary accuracy. And yet, the multiverse remains controversial, not because it is silly, but because it is difficult to test. Science, at its core, relies on observation and experiment. Predictions must be measurable. Hypotheses must be falsifiable. And the multiverse challenges these rules. If other universes exist beyond our observable horizon, if they are permanently disconnected, then how could we ever confirm them? This is the central criticism. Many physicists argue that without testable predictions, the multiverse belongs more to philosophy than physics. Others respond that science has faced this problem before. Atoms were once unobservable. Black holes were once mathematical curiosities. Gravitational waves were once impossible to detect. In each case, theory came first. Evidence followed later. So the question becomes more nuanced. Is the multiverse unscientific, or simply ahead of our tools? Some versions of the multiverse make indirect predictions. Eternal inflation predicts specific patterns in the cosmic microwave background, subtle temperature variations, anomalies in cosmic structure. So far, results are inconclusive, intriguing but not definitive. The many-worlds interpretation is even harder to test, because it predicts the same outcomes as other interpretations. From the inside, all interpretations look identical. This means the debate is not about math. It's about ontology, about what exists. And physics has always struggled when it reaches this boundary, because equations describe behavior. They do not tell us what reality is. Now let's address a quieter concern, one that often goes unspoken. If the multiverse exists, does that mean our universe is ordinary? Unimportant? This fear is understandable. Human meaning has often felt threatened by cosmic scale. But scale does not erase significance. A moment can be meaningful even if it is not unique. A life can matter even if others exist. Meaning is not measured by rarity. It is measured by experience. Your universe is the only one you will ever know. Your story unfolds here. No parallel version diminishes this one. Now let's touch briefly on conspiracies, because the multiverse often attracts them. Some claim secret evidence is being hidden. Others suggest governments know more. Still others link the multiverse to glitches in reality. There is no evidence for this. Physicists debate openly. Papers are public. Arguments are transparent. The mystery exists not because it is hidden, but because it is hard. Science does not suppress the multiverse. It struggles with it, and that struggle is honest. There is something quietly beautiful about this. Even at the edge of knowledge, even with our most powerful theories, reality remains larger than certainty. The multiverse, whether real or not, teaches humility. It reminds us that our perspective is local, partial, incomplete. When people hear about the multiverse, a quiet worry often follows. If every possible version of me exists, do my choices matter? It's a fair question, and a deeply human one. At first glance, the multiverse seems to flatten meaning. If every outcome happens somewhere, then nothing feels special. But this reaction comes from imagining reality from the outside, from a perspective no one actually has. Inside a universe, inside your life, outcomes are not duplicated. They are lived. You experience one path, one sequence, one unfolding story. And from inside experience, choice is real. Physics may describe many possible futures, but you only inhabit one. Free will, in this context, does not mean freedom from physics. It means participation in unfolding outcomes. Your decisions influence which future you experience, not by magic, but by causality. In the many worlds interpretation, all outcomes occur, but you do not experience all outcomes. You experience one. That distinction matters. Imagine standing at a fork in a road. Two paths diverge. Even if both paths exist in some grand cosmic sense, you still walk only one. Your feet feel one ground. Your eyes see one horizon. Meaning arises from commitment to a path, not from exclusivity of existence. This reframes fate. In some multiverse theories, fate is not fixed. It is distributed. All possibilities exist, but experience selects. From within a universe, uncertainty remains. You don't know which future you'll encounter. This preserves something essential: wonder. Now consider a softer implication. If there are versions of you who made different choices, who struggled more or less, who succeeded or failed, then compassion becomes easier. Every decision is part of a landscape of possibilities. Every outcome is one branch among many. This does not excuse action, but it deepens understanding. Now let's turn to a subtler idea. Some philosophers suggest that the multiverse changes how we think about regret. If every choice exists somewhere, then regret is not about lost possibilities. It is about present experience. You are not missing a version of life. You are living one. This perspective can be strangely comforting. There is no perfect path you failed to find. There are only paths taken and paths not experienced. Your life is not a comparison. It is a narrative. The multiverse does not judge narratives. It contains them. This idea echoes something ancient. Many traditions teach that meaning is local, arising from attention, from presence, from engagement. The multiverse oddly reinforces this wisdom. Even in an infinite reality, your moment matters, because it is the one you inhabit. For now, let choice feel gentle. You don't need to carry infinity, only the next moment. At some point, every grand idea in science reaches the same quiet crossroads. Can we test it? The multiverse is no exception. Right now, no experiment can directly observe another universe. No telescope can peer beyond the cosmic horizon. No instrument can measure a branching timeline. And yet, physics has never required direct observation alone. Atoms were inferred long before they were seen. Black holes were predicted long before they were detected. Gravitational waves were measured a century after they were proposed. So scientists ask a more subtle question. Does the multiverse leave fingerprints? Some versions might. Eternal inflation could leave scars in the cosmic microwave background. Faint patterns, unusual alignments, regions colder or warmer than expected. Researchers have looked. They continue to look. So far, the evidence whispers. It does not shout. Other approaches come from particle physics. If our universe is just one of many, then certain constants may appear unnaturally tuned. The mass of the electron, the strength of gravity, the expansion rate of space. Some physicists argue these values make sense only if many universes exist. Not proof, but explanation. Still, critics remain cautious. They argue that explanation without prediction is incomplete, that science must aim for falsifiability. This tension is unresolved. The multiverse sits at the edge of what science can comfortably handle, and that edge keeps moving. New theories may emerge, New tools may be built. New questions may reshape the problem entirely. It's possible the multiverse will one day be confirmed. It's also possible it will be replaced by something even stranger. Science does not promise answers. It promises progress. Now let's step back. Whether the multiverse exists or not, it has already changed how we think. It has expanded imagination, softened certainty, challenged the idea that reality must be simple. And perhaps that is its greatest contribution. The multiverse reminds us that our universe is not guaranteed, that its laws are not inevitable, that existence itself is contingent. This realization can feel unsettling, but it can also feel precious. You exist in a universe where stars formed, where chemistry became biology, where awareness emerged. That alone is remarkable. Infinite versions of you do not diminish this one. They highlight how rare experience feels from the inside. After everything we've explored, the equations, the interpretations, the doubts, the possibilities, we can answer the question carefully. Are there infinite versions of you? Possibly. Some theories suggest yes. Others remain undecided. None are proven. The multiverse is not a fact. It is an idea born from mathematics that works too well to ignore. It arises when physicists follow their equations honestly, even when the destination feels strange. But whether infinite versions of you exist or not, your experience remains singular. You wake up here. You live this life. You feel this moment. No parallel version replaces that. No cosmic duplication diminishes it. Science does not remove meaning. It reframes it. In a vast universe, or many universes, meaning becomes local, personal. You are not important because you are unique in all existence. You are important because you exist here, because awareness is happening now. The multiverse, if real, is silent. It does not intrude. It does not demand belief. It simply suggests that reality may be larger than certainty, and that humility is part of understanding. Tonight, you don't need to decide what's true. You don't need to resolve infinity. The universe has time. As you rest, let the question soften. Let it drift outward. There may be countless universes, or only one. But in this one, there is quiet. There is curiosity. There is rest. Thank you for spending this time with Science for Sleep. Until the next question. Good night, Crescent Moon.